Sorry about the delay. Got a very busy schedule this week in work, so well, thanks for coming. We'll just give it a minute, just to let people join. I know we won't have as many this time, just because it's an hour late. How's everyone's week going?
Going all right. Thank you.
Cool. There's been some fantastic work in the Slack. I haven't been responding to as many things recently. I've just bought a new house, so I'm doing all sorts of work in there, and my time is, in work and outside work, it's chaotic. So, but I've been keeping a check on things. I'm trying to follow as much as possible. So it's been great so far. So as usual, this is only a sort of informal catch up and whatnot. If anyone's got anything they'd like to share, any problems that they've ran into with the group, please go ahead and you can share your screen. It's not a problem. I've just allowed that. So I think always you and Team One have done some fantastic work, and you've got a meeting tomorrow, I believe. Have you got any sort of progress that you can share with the group today at all?
Hi, Rich. Hi, everyone. Yeah, so as you may have noticed, there has been a lot of activity going on in the in Team One channel, and a lot of people have been trying a lot of different kind of stuff. I have prepared a document uh, for keeping track of everything that everyone has been doing. So um, let me just share my screen and I will walk you through it quickly. Uh,
Cheers. Just give me 1 second. Someone's at the door.
yeah, okay.
Sorry about that. So this is a document basically of what everyone in your particular team are working on at the moment.
Yeah, so this is so after our second team meeting, during our second team meeting, we basically prepared three sets of training and testing data. Um, so in this table, each row corresponds to a single set of training and testing data. I call a single set of training and testing data a batch. So the first batch, the features that we extracted from the first batch were extracted. We didn't use any augmentation. We cropped the images and we used VG16 for extracting features, and we didn't use any feature selection or ensemble learning techniques, which we are planning to be performing in the future, in the coming days. And then the team tried training different type of classifiers on it, and the best estimator that we got was XGBoost, and these were the scores. Um, so as I mentioned, there was no augmentation done on the first page of that. I just wanted to have like a, a base model without performing any kind of augmentation or anything. I wanted to have uh, a base model for so it's something that we can compare to. So for the first page, it was obvious the recall and precision score for hem class were pretty low. The recall scores were pretty low. The precision scores are high. Yeah, and then on the second batch of data, augmentation was we performed augmentation. We cropped the images, and same we use VG16 for feature extraction, and the best model was again XGBoost. and the scores from of the scores of the second wave for the second batch of data were pretty amazing. And same for the third batch of data. So the third batch of data is almost pretty similar to the second batch, but in this one we used a bit a bit proper technique for cropping the images. So instead of cropping 30 pixels from each side of the image, Kiran, I think it was Kiran who came up with a brilliant solution to the cropping in which all the black pixels from each image are dynamically cropped. Uh, so yeah, so the scores were pretty amazing, but then turned out that these scores are misleading because the Mir noticed that we are performing augmentation on all the data before splitting it into training and testing. So it was then after doing some research, I found out that it was a classic case of data leakage. Uh, so that's why the results from these two batches are highlighted in red. Um, so yeah, after that we went back to work and uh, made two more set of batches. So in these two sets of data, we made sure that the data is split into training and testing first, and we only augmented the training data. So yeah, so this one was performed by me, and the second one was this one is performed by Neville. And he used ResNet for extracting the features. And we didn't share this data with the team yet, so there are no results for this data. But
Yeah,
we will,
not
yeah, we will
that's
be.
really good. In terms of like keeping track of the experiments, it's fantastic. And yeah, data leakage is always, it always gets in there somehow. And it's just you have to learn that it happens and have to deal with it. But yeah, I think that's really good, and I'm looking forward to seeing them results. Um, have you got plans for sort of? I know you've got the feature selection and ensemble learning. Do you have plans of when you're going to do that?
Yeah, so tomorrow, during tomorrow meeting, what we are going to do is that we will get results for these two batches, and then we will start another experiment in which we will be performing augmentation, cropping, and then we will include feature selection, and we will get results for that. And after that, we will generate another set of experiment, and for that, we will also be performing ensemble learning. So we will have like a bunch of results. So I'm trying to like get I'm trying to perform as many experiments as possible so we can like have a good idea of what's working and what's not working. um so yeah, feature selection and ensemble learning uh, is on the list, and it should be done during the next couple of weeks.
Nice. That's really good work. In terms of the ensemble learning, are you have you looked at any sort of techniques of how to do that? Any packages? There's one I've used before, VecStack, very easy to use, and quite efficient as well. Have you done any research into that at all?
To be honest, I have never tried ensemble learning before, but I have looked up a couple of resources on it, but they weren't using like any specific package for it. They were just like hard coding everything. So if you have got an idea, if you know a good package, please share it in the channel. Yeah, it
Yeah.
would be better to do it with a proper package than doing it like hard coding it.
Yeah, the one I've used is a VecStack, and it's pretty similar to scikit-learn, very easy to implement, and it saves a lot of time hard code and stuff. So I'll share the I think it's a GitHub repo that I used and followed along from, but I'm not 100% sure. But I'll send that over to you, not a problem. It's very effective, and I would suggest as well research what kind of models complement each other, um, because that is the point of the ensemble learning, is to use models that approach the problem in a different way, so you can take the advantage of the different ways of doing it, if you know what I mean. Where one model falls down, the other one should complement, and that should, hopefully increase the results that you're seeing. So just bear that in mind. There's probably little points if you ensemble like a XGBoost and a random forest, if you know what I mean. They're too similar, even though there is subtle differences in the way the algorithms approach the data classification. Use different ones that maybe where say if you're using support vector machine learning, that there's certainly pros and cons with that, and I think a gradient boosted tree would possibly complement that. But you're not limited to using them. There's thousands of algorithms out there, so just do a bit of research on what models complement each other when you stack them. It is quite important to do that. Neville, you got your hand raised.
Yeah, actually, about the ResNet model, I'm pretty much been trying to finish it by today, trying to do an SVM model on it and get some results. But the issue is that it's an absolute nightmare to train. It takes like a whole 22 minutes. And SVM is, as you said, pros and cons of SVM. It's not meant for large data sets.
Yeah.
So it's hard. But yeah, I'm trying to finish it by today. And then look, and also you had sent something about dimensionality reduction, that power predictive score. That is primarily meant for feature selection, right?
Yeah, that's right. Yeah. To put it simply, it basically looks at your independent features and see which ones have the most predictive power, based on mathematical computations. The GitHub I shared, it gives it a good breakdown of how it works and
Yeah.
whatnot. Yeah, it is more for feature selection. And I suppose in a way that is dimensionality reduction as well, because you can isolate them features then, and just use a data set with them in. But there's other methods, obviously PCR and things like that. Just it's worth experimenting with. They all work in different ways, and all of them have different levels of computational power. I think from memory, the power, what was it, predictive power package, that is quite quick, and you don't have to run the model either. You can run it independently, so it is quite good for computational speed as well. So it's definitely worth adding to the pipeline and experimenting with. And of course, yeah, try traditional methods, PCR, t-SNE, and things like that. It might be interesting to look at.
Okay.
But I've just found that VecStack package, and I'll just put the GitHub repo in the knowledge sharing thing there. Very simple to implement, and you can just do a pip install on it, and it's just like it just incorporates into scikit-learn. Very easy. You just add it to your pipeline. Cool. Has anyone got anything else that they'd like to share with the group at the moment? Anything they're working on? Any experiments at all? Any questions about what's being done so far? Everyone's done really well. There's been plenty of activity, and it's good to see a lot of different experiments and a lot of different techniques people have been implementing. I've been very impressed. But yeah, keep track of those experiments, because it'll be good to have a write-up at the end of the project, and we can put all the ideas that we had together and show people what worked and what didn't work, and it's very thorough. Some of the scientific papers that I've looked at that have used the same data set, a lot of them have done it quite rudimentary, done it quite they haven't performed as many experiments as we have in terms of cropping, image augmentation, and things like that. And at the current the current scores that we can see, even in our baseline model, are better than some of the scientific papers have seen, that use it in the same way Team One are doing, by extracting the features and applying traditional methods. So I think we're in a very good a very good place at the moment. I've been very impressed. But yeah, has anyone got anything else to share?
Yeah, I just wanted so you mentioned the scores and everything that so I just wanted to like share it with everyone that uh Rich, I'm sure you are very familiar with this because during our previous project it was also an imbalanced data set case, and in this project as well. So the accuracy scores that we are getting is good. Like even on the even the best model is reaching up to 83-85% accuracy score. But the problem is with the him class. So the score that we are getting for him class is not very good. The false negative number is quite high. Um, so yeah, it's something that has got me a little worried. Uh, because the
Yeah,
images that yeah, by the look of the images, it's it's just I am just assuming it, but it just looks like augmentation will is not going. It's just like I said, it's just my assumption. But just by looking at the images, like the images are in a way that if you rotate it or if you flip it, it does not seem like there is much happening to the image. They all look similar. So I'm a bit worried about it, but yeah, we will see where it goes. I just wanted to share it with everyone.
yeah, of course, it is something that does skew the results. And I think what's important as well is to remember that because this is, where if this was in industry, we'd be trying to deploy this model to aid people in real life, try and make these diagnostics as well. So your evaluation metrics need to be important as well. So it was mentioned in the expert session with Dr. Neil Barrett. Um, yeah, accuracy, precision, recall, they're all great, but there's other metrics that they use in the medical industry. Like I hate saying this because I can never say it, specificity. I think that's how you pronounce it. It's just one of them words, and it's being able to calculate those sort of metrics as well. I think they should be included in our analysis. I'll share a paper of the mathematics behind it, but I'm sure there's probably scikit-learn and things like that. I don't think I've actually used it for any like the metrics like that, but I'm sure they probably cover some sort of medical metrics as well. If not, it can be done customly in a little function. It wouldn't be a problem. But I'll share a couple of resources on that as well because it is quite important. We can't rely on just the standard machine learning metrics because if you have to imagine if you're in a real life situation, if you get the incorrect diagnosis, someone you say no, this person hasn't got um, leukemia when they have, it's very, very bad. Of course, this isn't the only way they diagnose it. There's plenty of other tests which would verify that. But I think just in terms of best practice, more robust metrics, just to double check what we're doing is correct, is probably a good idea. And I think it would be good for the group, and specifically, and especially team one, to look into these different types of medical metrics that they use, what they currently use in AI when they're classifying diseases or whatever it is. So yeah, that is something to take into consideration. I wouldn't necessarily worry about that until the end, though, because at the end of the day, if you're running all these experiments, you've got all them metrics that are sort of standard to machine learning, and what you can do is based on them numbers, you can derive the different sort of medical metrics like specificity and things like that. So yeah, I wouldn't worry about it too much, but I think incorporating that will not only show that we've thought about this very thoroughly, but it's also a good learning curve as well, and to show that if you want to enter the machine learning world through a medical route, it's good practice and it's good domain knowledge as well. But as I say, I'll share a couple of papers on that, and we can, and you can take a look and just when we get to that point, we can start applying them metrics and see how good the models really are in terms of a medical diagnosis. Okay, so just a few chats there. Let's have a look. Neville, you've shared one. Yeah, this is a great paper. I've seen this one before. This is quite a popular paper actually in terms of medical metrics. So I'd take a look at that. Some of them, as I say, we've already covered, but you know, there's a few more there, like Matthew's correlation coefficient, you know, threat score. So some of them may not apply, but it's just worth looking at, and it's worth expanding your knowledge on them and applying them to the project as well, just to make sure it's complete and it is specific. It's not just a, I don't want to, you know, you're going to be using this project as part of your portfolio, and I don't want you to go away with the sort of half-baked project. Applying these medical metrics will take it from a mediocre project to a very, very strong project. Of course, all the experimentation that you guys have been doing, absolutely fantastic. It's probably, you know, it is already a strong project for the portfolio. But what I'm saying is take it a step further. If you want to get into the machine learning medical world, things like this will make the difference between success and failure. And you know, even if you apply them and get a sort of basic knowledge of that, it's going to be beneficial. You don't have to be an expert, and you know, it's just something to be aware of. So yeah, take a look at that report, sorry, that paper that Neville's posted, and I'll just paste it in the knowledge sharing channel as well. But yeah, okay, thanks very much for that, always. I think, you know, the work that you've done is fantastic. Does anyone have any other questions, any other work to share? No, that's cool. If you do any work outside of your team just to experiment in it, and if you do that in silo, please push it to the GitHub repo, and also just share it in the Slack channel as well, so we've all got visibility on there, because you know, you might uncover a couple of gems that may have been overlooked. It's very important, if you do any research, just to keep the other participants in the project aware as well. It really helps. The more brains we have at it, the better it is. So yeah, I appreciate if you do that. But if no one else has got anything else to share or any questions, we can call it a day there. As I say, very casual, very rough and ready. And what we'll do on Saturday, always, I know you're meeting tomorrow with your team. If you can not prepare a presentation, but if you could just run through what you've done so far in terms of experimentation, the two experiments that you've got that you haven't got the metrics for yet, if you could walk us through them with the whole group, that would be fantastic as well. Just so you know, you're ready for Saturday kind of thing. And I'll speak to Pranjal as well, because I think he's had a couple of meetings so far. So I'll catch up with him and see if he's got anything to ready to present on Saturday as well. And I think we're on track. We're doing really well. Plenty of knowledge is being thrown about, and I hope everyone's learning something, especially the beginners as well. Any beginners that are still a bit confused about what's going on, reach out to me, reach out to Oasis, reach out to Pranjal as well, and I'm sure they can make time and explain what's happened over the past like 2 or 3 weeks. And yeah, I think after our experiments have been done, I know you could experiment forever, but I think we'll have to decide at a point when you know, we've done enough experiments, we've got a model that's performing well. We can start talking about the potential to deploy this model into a web app of some description. So yeah, I think maybe not this week, maybe not next week, the week after though, I think we'll have to start having, you know, some serious talks about how we're going to deploy this. And we, you know, the deployments serve two purposes. One, it's good to deploy a model like this where other people can test it and whatnot. But two, it gives you something for your portfolio that you can link to in your resumes, on your LinkedIn, on your portfolio website or whatnot. It's always great to have a working app rather than just explain how it works to people, if you know what I'm saying. So yeah, we'll start talking about that. Not this week, not next week, the week after. So 2 weeks time. Okay. Well, thanks for coming, everyone, and I'll give you the rest of your day back. Any questions in the meantime, just pop them in Slack, and have a good week, and I'll see you on Saturday. Appreciate you attending, and I'll see you soon. Bye-bye.
Thank you. Bye.
Bye.
Goodbye.